a hackathon challenge basically aiming at enhancing the accessibility for individuals who are blind or visually impaired. The challenge basically focuses on developing a deep learning model capable of generating a descriptive caption for an images and enabling the users that are blind to gain the meaningful insight from the visual content. And for this, we have come up with the solution of an app named ImageSpeak, which is going to generate a descriptive caption for the images clicked by the blind users and enabling them to get the meaningful insight from this picture. And for this, we have integrated a deep learning model BLIP in that application, which is capable of generating a caption for the images clicked by the user who is blind or visually impaired and enable them to get a meaningful insight from this content. And we have also utilized the text-to-speech Google API in order to provide the speech output functionality for our application. For the workflow of our project, we have to move to the next slide. That is workflow description. As you see, this is our workflow of our project. The user that is blind is going to click a picture from a mobile app, which is basically based on a Flutter framework that can be opened on Android or iOS devices. And the picture clicked by the user is going to be processed by our BLIP model that is going to generate a caption, which is a very descriptive details of the images, and this caption is going to be converted to a speech output using a Google text-to-speech API that provides speech output functionality to our application. This is all about the workflow. Talking about the technologies that we have employed for the Android app, we have used the Flutter, ImageSpeak, Dio, and for the deep learning model, we have used the BLIP in order to generate a caption, and for the visual function answering, we have experimented with the BLIP 2 and used the BLIP 1 model. Next is the app functionality.
Backend of our ImageSpeak application was deployed in Google Cloud. So we had used a web API service called Fast API, which is a Python-based web API service. We had deployed it on Google Cloud using Docker. We had Docker containerized the web API, and we had hosted it on VM instance in Google Cloud. We took 2 VM instances for deploying 2 models, that is one for question answering and one for the image description. After deploying to the Google Cloud, we had tested out using Postman that our IP is working with our port forwarded from 8000 to 9090, and after port forwarding, we tested out our application, our Android application, which was working with the IP address and the port number, as you can see.
Start by capturing a picture. You can start clicking picture by using the volume button to open the camera and tap to snap.
Press volume button to capture. Open camera. Tap to capture. Picture clicked. Please wait. This image shows a view from a balcony looking out at a house with a lake in the background. Thank you. Double tap to ask questions. Open mic. What is your query? Your question is there? Answer yes.
We will see the model implementation in detail. The BLIP model that we have used, that is the 2 contribution, that is basically one is the multi-model mixture of encoding and decoding. That is it can be used as a unimodal encoder, image grounded text encoder, or image grounded text decoder. And this is going to be trained with the 3 functionality, that is information text contrastive, image text matching, and image condition language modeling. And next, in the downside, you can see the flow of the training of the model. And for the visual question answering task, we have experimented with the BLIP 2 model. Talking about the BLIP 2, BLIP 2 is a generic and efficient pre-training strategy that bootstraps the vision language pre-training from off-the-shelf frozen pre-trained image encoders and frozen language large models. And talking about the BLIP 2, it bridges the gap, that is the modality gap, with the lightweight querying transformer, and is pre-trained in the 2 stages. Talking about the first stage, it is basically a bootstrap vision language representation learning from a frozen image encoder, and about the second stage, bootstrap vision to language generative learning from a frozen language model. And that's the visual question answering is experiment with the BLIP 2, and we have also used the BLIP 1 based visual question answers that you also can see here. This is the input image, for example, and we have used such kind of question to train the BLIP model. And now, so what is the unique features in our project? Talking about the unique features in our project, we have assisted the whole app with an audio that is going to make the user experience smooth, and we also have the intuitive camera activation, that is it can be opened by a volume up down button. And next one is the interactive query, that is we have enabled the double tap in order to enable the user to ask the question about the images that it's clicked, and this enhances the engagement and usability. And next one is the containerized deployment. And talking about this, we have used the Docker containerization in order to deploy our app. This ensures the faster inference and reduced latency and overall optimizing the performance. And last one is the cloud and edge model deployment. That is, we have deployed the model on the Google Cloud for the scalability and the edge for the real-time processing. That is going to benefit the user from a versatile and responsive system.